connected to a fixed capacitor in series with a fixed capacitor of 8.2 picofarads. And this brought the things back into frequency, right into frequency, and it also allows for a little bit of overhead. If you see the trimmer there, it's not fully open. It allows for a little bit of overhead too. So yeah, I'm pretty happy how it turned out. We are right on spot here. So I'm gonna close this unit now and let it heat again and check the rest of the frequencies for correct operation. Okay, here's the final test now. The unit is closed and I'm gonna check for the right tuning of my transceiver, my Collins transceiver on the modern one. And let's check it. 1, 2, 3, 4, 5. Yes, it's right on spot. So I just tune it now. Click the tune, and we're right on spot. And let's do, in fact, another test. Let's say we want to go to 7.190. Okay, so I'm tuning here and I'm going to 7.190. Without looking at the digital dial of the modern transceiver, it will be just about here. It's difficult to set that from this analog transceiver. I think it's here. Yeah, something like here. Now let's go back to the transceiver and go to 7.190, and let's check now the let's check once again the tuning here. No, let's check the SSB operation. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's pretty close, isn't it? A little bit off, and we can see this. Somewhere here. I think we're on spot now. Now let's see how it will turn out on the SSB. 1, 2, 3, 4, 5. Yes, 1, 2, 3, 4, 5. Yeah, I think it's quite usable. We are right on spot. We have maybe a few tenths of hertz of difference. We can always bring that to the ear with the other ham operators that operate on modern transceivers. But the point is that we now don't depend on the analog dial only, and having to always calibrate on the nearest 100 kilohertz. And the problem, guys, with this is that if I zero bit at 7.2 megahertz, then if I go to 7.190 or 7.180 or 170, for example, despite these VFOs are quite linear in these old Collins, they're still not linear enough. So I'm losing a few hundred of hertz, maybe more sometimes, and I don't really know the exact frequency I'm on. And I can demonstrate you this. Let's say I want to let's basically see the point now. Even with those very linear oscillators, you are well out of a few hundred of hertz, maybe more sometimes. Okay, that's the best case scenario. These are very linear oscillators, but other transceivers might be more worse. I don't know. But anyway, with this simple trick now, we can check exactly the frequency, and let's bring it back to down to exactly to 7.1 to do a small test again. Okay, I think we're close enough here. Okay, so let's do the test now on lower sideband. Are we exactly on 7.1? Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, we're right on spot. Right on spot. So, the whole point was to put a small series capacitor within the along with the main trimmer that sets the crystal frequency, the reference frequency, in this frequency display, and then tune it so that when you want to be exactly on frequency on lower sideband or high on or upper sideband, and you talk to your from your transceiver and you monitor the signal on another transceiver and try to correctly align your transmitter here, then when you switch to the tune, we set this frequency display so that it matches exactly the frequency of the modern transceiver. Okay, and because the receiving and transmitting frequency on this set is exactly the same, we can safely assume that the receiver frequency is exactly the one shown in our frequency display. So that was it for now. Thank you very much for watching. I hope you enjoyed the video and learned a few things along as I did do. Thanks a lot and for watching.